Okay, these are the notes for 9.0 transformations. This is a review unit, and the notes are being done differently today because I really need the flexibility of some paper to move things around. So I'm going to quickly go over what I have up on the screen, and then I recommend you pausing this video so you can write it down. So, transformations are a subject that is previously studied in middle school and reviewed in Math 1. And so, just to go over, kind of get the gears moving here, the original figure is called a pre image, all right, something like ABC. The figure after some sort of transformation is called the image. So, the initial is pre image, and then whatever I get at the end is going to be an image. Now, these little apostrophes are called prime. So this is A prime, B prime, C prime, D prime. If I have more than one transformation, we're going to see that we're going to have more than one of the prime symbols. There are three different types of rigid transformations that we're talking about today. Rigid just means that the figure does not change size or shape. We're going to talk about translation, reflection, and rotation. And in my opinion, these go from like easiest to a little bit more complicated. So a translation is just a slide, like when I move it left, right, up, down. And it's going to be represented by a capital T. These like triangle kind of brackets here are a subscript. And then however I move in the X direction first, however I move in the Y direction next. For reflection, I can technically reflect over any line. The only ones we're going to be doing here are going to be the X-axis or the Y-axis. Translations represented by a capital T, reflections represented by a capital R, rotation is represented by a lowercase r. Now, this subscript is going to have the degree of the rotation and about which point that we're going to rotate. I can rotate about any point, although we will only be rotating about the origin. And then my degrees of rotation, to keep things simple, are going to be some denomination of 90. So it could be 90, 180, 270, 360. Okay, nothing in between. And then just a reminder down here, when I am moving about a coordinate plane, I am rotating counterclockwise. So like I recommend, go ahead and pause this, copy this down, make sense of it a little bit, and then we will jump into the notes. Okay, so I'm going to come over to these pre-printed notes. My hope is that these are getting copied down into your notebook, and then these pre-printed notes you can paste into your notebook when you are finished writing on them. All right. In this example, so you'll see transformations review. One, apply the transformation to quadrilateral CDEF. And if you glance at these notes, the front and the back, they all have the same figure CDEF, which kind of makes it easy and nice. Here is the pre-image. Here are the coordinates of the pre-image. We're going to perform this transformation and get a new image. So my transformation right here is right here. Capital T is going to be a translation. That means I'm just going to shift it. All right. The first number here is what's going to happen to the X value. The second number is going to be what happens to the Y value. So this is going to translate. Let's see, the minus 5 for X is going to be left 5. And then the 2 in the Y direction is going to be up 2. Now you can choose to move the coordinate on your picture and then write down the X, Y value over here, or you could change the coordinate and then graph it. Either one is good. So I start here. For example, I have CC. I'm at C, which is 3, 3. Translate left 5 and up 2. So from here, I'm going to count 1, 2, 3, 4, 5, and then up 2. Here's my new C value. I'm going to mark it as my C prime because it's going to be part of my image. What is that new coordinate? It's -2. Let's see, 1, 2, 3, 4. These don't have a scale written on there, but I recommend doing it. So my new coordinate is going to be -2, 5. When I move D, left 5, 1, 2, 3, 4, 5, up 2, D prime. That coordinate looks like -4, -1. Now, I could also use the coordinate here. So I could subtract 5 to get -2, and I could add 2 to get +1. I could also get my coordinates that way and then go left 2, up 1. Here's my new E value. So I can move whichever one that I want. So for F, if I go left 5, that's going to bring me to 0. And if I go up 2, that's going to bring me to 1. So 1, 2, 3, 4, 5, up 2. When I connect these, I'm going to connect them the same way that they're connected in the picture. So C to E, C to D, D to E, E to F, F to C. I'm going to use a straight edge to do it. And I'm going to move right through these notes, but if you need to pause them, I encourage you to do so. Please take your time on here. That's the beauty of the notes, to go at your pace. And that's our first example. Example number 2. A different transformation. Apply the transformation to quadrilateral CDEF, and this time I am capital R. So I said capital R was a reflection, which you should be able to tell because I have this y-axis here. I have some line named, and I'm going to reflect across the y-axis. Description of that transformation. Reflect across y-axis. And we've been talking about axes of symmetry lately and how to reflect. So hopefully this doesn't feel too tough. I know that it's so small, but there is really like a teeny tiny X here and a teeny tiny Y here. 2, 3, 4, 5. I want to 2, 3, 4, 5. Make sure that my axes are labeled. Okay. So when I reflect, I'm going to take this and I'm going to reflect it across the y-axis. When I reflect across the y-axis, I want to preserve the distance. So here's what I'm going to do. Here I am at C. I want to reflect across the y-axis. This is currently 3 units from the y-axis. So I'm going to go 3 units past the y-axis to get the new coordinate. What is that coordinate? -3, 3. And same thing with D. Right now I am 1 unit away from the y-axis, so I'm going to go 1 unit in the opposite direction. Here is D prime. That coordinate is -1, -3. E is currently 3 units from the y-axis, so I'll go 3 units out. And F is 5 units away from the y-axis, so I'm going to go to the y-axis and then 5 more units. Connect C to D, D to E, E to F, and F back to C. It looks like a nice reflection, right? Whatever's happening on the left is the mirror image on the right. Now, for a lot of these transformations, I can come up with rules. So if you kind of study what's happening between the pre-image coordinates and the image coordinates, you'll see some rules that we can come up with here. And so the rule here, and this is only going to work for a reflection across the y-axis, is that the x value just becomes the opposite. So if it was positive, it becomes negative, and if it were negative, it would become positive. And so the rule is going to be that I take the opposite of x and keep y. Now, some people are much more visual learners and this works better for them. Some people would rather memorize a rule, so there's a rule if it's helpful to you. For problem 3, we're going to use some patty paper because rotations are just really tough without it. So let me move this up. This lowercase r, all right, means I have a rotation of 90 degrees. And then the O there means about the origin. Okay, so this is going to be rotate 90 degrees about the origin, which is 0, 0. So everybody hopefully has been given a piece of patty paper. If you don't have a piece of patty paper, and if you have a tracing paper, if you're at home and you have some parchment paper, here's what I'm going to recommend that you do. Put this on top of your image. I'm sorry, on top of your pre-image. Be more careful with my language. And I am going to go over the X and Y axis. And then I'm going to trace my pre-image. Okay, so take a moment, trace that. Pause this if needed. And a reminder that when I am rotating counterclockwise. So here's the tip for success here. You're going to put a pen, a pencil, something, some kind of tip on the origin. This gets rotated about the origin as indicated by this O. So what I'm going to do is I'm going to move my top paper 90 degrees. And 90 degrees is a quarter of a turn. So let me go back and I do that again. Okay, so here's my original figure. A quarter of a turn means that I am going to turn this and I'm going to put my x-axis on top of my y-axis and match it up just like that. So holding that where it is, now I can, this one you're going to do a little backwards. I'm going to do the coordinate first and then I'll put it on my graph because I need to find, where's this point going to be? This new point is going to be -3. 3. D prime is going to be 3, 1. E prime is going to be 1, 3. And F prime is going to be 1, 5. Then I'm going to remove my patty paper and actually draw it there so I can see it. Recreate this image, connect C prime to D prime, D prime to E prime, E prime to F prime, and F prime back to C prime. And now I have a rotation of 90 degrees in a counterclockwise direction. All right. Now, each time I rotate for a different number of degrees, my rule is going to be different. So for this time, I rotated 90 degrees. and I could write a rule for that. What happens is it's easier to see for D, is the 1 and the -3 change spots, and then the first term changes sign. So I'm going to have -y, comma, x. X and y change spots, and then the first one changes signs. So there's a rule for 90 degrees, there's a rule for 180 degrees, there's a rule for 270 degrees. You also can just rotate 90, then rotate 90, then rotate 90. Okay, hold on to that patty paper because we're going to end up using it again. All right. Question number 4 is a reflection across the x-axis. I always reflect about a line and rotate about a point. So if you see the x-axis here and you can't remember, is capital R reflection or rotation? If I'm going across a line, it has to be a reflection. And this figure is going to kind of end up being on top of itself. Because I'm going to take this and now I'm going to reflect this across the x-axis, which means it's going to kind of spin about this. It is going to spin about this point. It's going to kind of land on top of itself. So when I want to reflect, I'm just going to duplicate the distance. So C is 3 units from the x-axis. And I'm reflecting across the x-axis. And so I'm going to go 3 units in the other direction to get C prime. D is 3 units from the x-axis, so I'm going to go 3 units in the opposite direction to get D prime. E is 1 unit from the x-axis, so I'll go 1 unit past and E prime. F is 1 unit away from the x-axis, so I'm going to go 1 unit past. And then connect. C prime to D prime, D prime to E prime, E prime to F prime, and F prime to C prime. Trying to get this cool star looking shape here. Oh, I didn't write about my transformation. My transformation is I reflect across the x-axis. And just like for my other reflection, I can make a rule here. So what happens is my x value is going to stay the same and my y value is going to switch. So my x value is going to stay the same. My y value is going to, if it's negative, become positive. If positive, become negative. So 5 - 1 becomes 5 + 1. So this is x, -y is my rule. Like I said before, some rules help people. Some people would just rather visualize it, get out a piece of paper, and graph it. Number 5 is different. You may have never seen these before. You probably haven't. You will recognize, hopefully, this little symbol, this little O in here. And remember that this is composition. Okay, I'm just going to make a note. Where do I want to make a note? Where will it fit? Composition. I don't know where this is going to fit. Composition. The whole reason we studied composition in topic 6 is so that we could apply it to topic 9. I am going to bring another color into this because what I'm going to do, first thing first, everybody stop what you're doing. If you are writing this from the notes on the year that I made it, this originally had a translation of 1/6 and I changed it to 1/3. So check and make sure that your copy says 1/3. So everybody stop, everybody look, Does yours say 1, 6 or 1, 3? Cross it off if it's a 6 and write a 3. The 6 doesn't fit well. All right. When I'm doing transformation or composition, I want to do the inside function first. So first, I'm going to translate. Remember, the 1 is the x direction, the 3 is the y direction. So I'm going to translate. 1, that's positive, so it's going to be right. And the 3 is positive, so that's going to be up. I'm going to do that part in blue, and then I'm going to rotate 270 degrees. So here, order matters. I'm going to translate and then rotate. This is still possible with the patty paper. Got to be a little more creative. Okay. So I'm going to translate first. So 1 right, 3 up. So each point, 1 right, 3 up. Here's C prime. 1 right, 3 up. D prime. 1 right, 3 up. E prime. 1 right, 3 up. F prime. Now, this is not my final answer. This is kind of like showing my in-between steps, showing my work. Still valid, still want to see it, but not the final answer. If you've got a fresh piece of patty paper, you could trace C prime, D prime, E prime, F prime. I'm just going to use this same one and show you how I can reuse the same picture. So I've got the same picture there. I lined it up with my blue one. Here's the trick though. My axes are no longer lined up, which is not a problem. But I want to make sure that when I rotate this on the XY axis that's on the paper underneath. So look where my pencil is, because I need to make sure that I rotate 270 degrees from the origin, which is the mistake I made the first time I did these notes. So from here, I rotate 90, 180, and 90 more gets me to 270. Oh my gosh, you can't see that. My hand was blocking it. Let me do it again. Okay, let me start over. Okay, so I've lined up A prime, C prime, D prime, E prime. I'm sorry, A, B, C, D, E, F prime. Whatever letters I've got there. And I'm going to rotate it. Let's try again. So my pencil is on the origin of the paper underneath. It's not here. It's here. So I rotate 90, then 180, then one more gets me to the 270. Now, I recommend writing down those coordinates before you move this paper to try to graph. And so let's see. This is 1, 2, 3, 4, 5, 6, 2, 3, 4. So this is 6, -4. I'm counting from the origin underneath. I have 2 primes here because this is called C double prime or C prime prime. Because I moved it once, that was C prime. Moved it twice, that was C prime prime. D is going to be 0, -2. 2, 1, 2, 3, 4. E prime prime is going to be 2, -4. And F is going to be 1, 2, 3, 4, 5, 6, 2, -6. We're going to be doing more composition of functions when we get to 9.2, which is why we're introducing it here So 9.1, we're going to do dilations, put it all together. So now I just need to go back and I need to plot these points. So 6. So 6, 1, 2, 3, 4. Here's C prime prime. 0, -2. Here's D prime prime. 2, -4. I know that I may be faster at graphing than you. So like I've said, please take your time. Pause this video as needed. C, D, E, F. There we go. And that's my final answer. And one more to go, and then you can work on the practice. So 5, I know it's unique. It's something that you haven't seen before. Just remember that just like all the other compositions I've done, I'm going to do whatever operation's closest to C, D, E, F, and then the outside one. So first and then second. Yay. Just an exposure to that today. I know that part's new, but, just getting you warmed up. All right, the last one. 6, apply the transformation to quadrilateral CDEF with a rotation of 180 degrees about the origin. So I'm going to rotate 180 degrees. And we could put about the origin here. If we don't, it's assumed it's about the origin. Now, again, you can rotate about any point. You'll notice that mine has a point P printed on here. Yours may or may not, but we're going to rotate about the origin, which is 0, 0. I'm going to go back to my handy dandy patty paper, line up my X and Y axis, put that right on top of my figure. Put my pencil or my pen on my origin, and I'm going to rotate 180 degrees. So that's going to be 90 and then 180. Now, patty paper is a great tool. You can use this. There's more patty paper in class that you can use on the worksheet. Please grab another sheet. And then I'm going to go ahead and copy down the coordinates before I move my paper. -3, -3, -1, 3, -3, 1, and -5, 1. Oh, I went the wrong direction. I went up 3, not down 3. Excuse my error. -3 and -3. That makes more sense. -1, 3. There we go. Sorry about that. -3, 1. And then -5, 1. The rule for rotating 180 degrees is that both signs change. So if this was 3, 3, now it's -3, -3. 1, -3, the 1 becomes negative, the 3 becomes positive. So it's going to be a -x and then -y. All right, and that sums up our review of transformations. In 9.1, we're going to look at what's called dilations, where we're going to enlarge and shrink the figure. So more stuff to come. All right, awesome. Thanks, guys.